Okay, welcome to another section for the training program. In this exercise, we're going to look at the advanced example for adjusting feed composition from Excel for this flow sheet, whereby we have got a flash unit operation being fed from the tank. So I just want to dissect more about this exercise. So this is just a simple sort of like a flash distillation exercise, whereby we are supposed to be controlling parameters to do with feeding into the flash drum, and also controlling the parameters to do with the vapor pressure and feed rate, also controlling the liquid rate and the liquid pressure. So this is sort of like this schematic that is shown in this exercise, whereby this unit operation is our flash drum in MedSim, being fed from the composition that is prepared from the tank, whereby we are feeding nitrogen, oxygen, and water vapor into this tank, mixing tank, and also we control the prepared feed for the flash drum. So you recall that the components that we are dealing with in this exercise include water, nitrogen, oxygen, and water in the gaseous phase, that is water vapor, right? So just giving it as a background, these are the parameters that we'll be interested in extracting into our spreadsheet. So after completion of this exercise, you are supposed to have an Excel spreadsheet that we will link the inputs and the outputs, and that we will run directly from Excel, whereby we'll be running MedSim in the background by linking Excel and MedSim. So we are supposed to get data to do with our flow rate, stream number 7, which is the vapor stream here. We're supposed to have flow rate and the temperature. In the flash, in the slurry stream number 8, which is the liquid phase, we're supposed to have the temperature, the pressure, and also the flow rate as output. And in the water stream, we're supposed to calculate the amount of water that is needed to be fed into the flash drum, right? So we'll be able to change the different input to do with weight fraction for each feed component, like the nitrogen, oxygen, and water vapor. So we can change this and run MedSim and extract the corresponding output variables. So the purpose for this exercise is for you to know how to set dynamic data exchange, and also how to use scalar variables as part of your control and as part of your APL programming. And also we're going to link this with our Excel using the dynamic data exchange feature for MedSim, and automatically run MedSim from the background using Excel. So just a quick rundown on this module. The first step is for you to set up this your model like this. You configure your parameters. You're going to check the mass balance, the heat balance, 8-vet dynamic data exchange, because we're going to set and link this to Excel. You also need to tick on the heat of mixing switch, HTM, right? And we're going to deal with metric tons per hour according to the exercise. Then you click on OK. Then you add your tank. Use the TNK. So this is going to be your nitrogen. This will be your nitrogen. Your oxygen, your water vapor, according to this exercise, to the specifications in the exercise, right? So your nitrogen is going to be 10 metric tons, weight fraction 100%. Your oxygen is also to be 10 metric tons. Your gaseous water vapor is going to be 10 metric tons at 50 degrees Celsius. Your water is going to be 2 metric tons. So these are the respective flow rates that are going to be added here. This is nitrogen. This is oxygen. And the respective temperature. And also this is water vapor. Metric tons again. Right, and also this is water that is going to feed into the flash drum, 2 metric tons with the respective temperature. Right, so you specify your composition, obviously after adding the components. So these are the components. And also just to give you a glimpse on the flash drum operation. So if you edit it, you will see that this unit operation, it simulates a flash vessel or a scrubber. Water is flashed to the gas phase at a specified absolute pressure, right? So these are the parameters for this unit operation. So like I was saying, this is quite the same as this this operation. So pressure, temperature, vapor pressure, liquid pressure, flow rates are important parameters that we would need to play around with, and also controlling the amount of feed and controlling the pressure and the temperatures for this unit operation. Right, so after setting up your flow sheet like this, you need to add also the control, setting up the flash vessel. So you still need to set the pressure to achieve 65 degrees in the slurry feed. The slurry feed is this stream number 8, the stream that is exiting the flash, right? So to achieve this, we need to insert a feedback controller on the flash vessel. So you incorporate a feedback controller, click it on, right? And it's going to take effect on the unit operation number 3 in this case for my exercise, which is the flash drum. So you have to note what we are going to manipulate is not a stream. We're going to manipulate the unit operation itself. So there is no stream that is to be adjusted. It has to be zero because we are using this feedback controller on the unit operation, not on the stream. So we would need to control the temperature for stream number 8 to achieve a certain temperature, which is 65, right? So instead of incorporating 65 here, we're going to use a scalar variable, which will always recall a value for this temperature. So this scalar is US/temperature. So I've copied this. Right. So this scalar US temperature is 65. So if you execute it, it will recall that, and this is the scalar which will be created in medicine, right? So you insert this scalar as a set point. Why we use it as a scalar? Because we would also want to export it into Excel so that we record it in Excel. Right? As this variable. So whenever that we change this variable as input, right, we would want it to automatically give a value to this feedback controller, so that the flash drum will operate according to the temperature that we had specified in Excel. So instead of putting just a value, we need to put a scalar variable that we can manipulate in Excel. That's the reason why we are using this scalar variable, right? So you need to also specify the unit operation control tab. If you recall this, or edit this, you recall that there is on the controls tab, there is controls to execute before unit operation, and there is controls to execute after unit operation, CTA and CTB. So this can form part of the control logic. This can form part of your control logic. So PR is the pressure variable, right? Which is let me show you, which is this variable, which is the pressure of the flash. So in MedStream, if you type PR, it will recall that same variable. That is the value. So MedStream understands this. So we can form, according to this exercise, they are forming this APL function where PR is going to be assigned a value that will be recorded by this value function 3 FRND CT VCT L5, right? And 5 is the unit stream number. So we're going to test this in the APL function keyboard. So PR is going to be given a value. You use this reverse arrow, 3 frnd vctl5 so it returns this value, right? This value function. So we've assigned the pressure for this unit operation to be assigned by this value function. So we just copy it, we go on to the controls, then we insert PR here. So PR, we will recall that this is the same variable. PR will recall this value function at any given time, right? So we've assigned this, but we will just take the PR and assign it as part of our control for the unit operation, right? So the software will put into account controls to be executed before the unit operation. That is that will take effect on the feed stream that we are adjusting. This is stream number 5, right? So I just wanted you to highlight this, and you do the same after on CTA flash pressure. The flash pressure is also going to be assigned a value of the PR. So this box that you are seeing here is it's supposed to show the sign, the reverse arrow. So this one is assigned the value for PR. So already the software understands what PR is. And if we execute it and take this variable flash pressure, the software is now going to understand what flash pressure is. If we execute it, it gives us a value. So we now assign this flash pressure as part of our control as well. Yeah. Then we click on OK. We save our module. So these are the steps, and this is where you find how you incorporate this control strategy, right? So this is the explanation for the value function 3frnd and nv. This is a function that returns the rounded off vector nv to 3 decimal places. So you can look this function in your math functions or in your value functions here. Then you can have the description of the function. So after that has been done, you need to create scalars for feed flow, scalars for nitrogen weight fraction, oxygen weight fraction, and water weight fraction, right? So these are just the user created objects that you need to create. So you use the US, this one, click on new, you click on Scala. So it automatically gives you US Then you need to type, this is US for nitrogen, and to weight fraction, right? Then you click on OK. Then for oxygen, you do the same, O2 weight fraction, you click on OK until you finish all the user created objects. All right. So the reason why we are creating this user created object is that we would want to link them with our Excel. You see that this scalar temperature. These values here, this is US feet, these are the same scalars. This is the weight fraction for nitrogen, this is the weight fraction for oxygen, and the weight fraction for vapor. So we would need to alter this as we progress with the exercise, so that we can vary this and run medicine in the background and automatically extract the corresponding outlets values after running the simulation. So that's the reason why we are creating the scalar objects. So you just create these scalar objects in your MedSim. So you also create the badge. To create the badge, click on new and click on badge, then click on OK. Right. So once you have created those user objects, you would need now to create a dynamic data exchange. Remember from level number 1. So for you to create this, you need to make sure that you've specified, you've activated dynamic data exchange on your calc options. Then you click on the dynamic data exchange, right? So you would need to create all these dynamic data exchange according to input or according to output. Like feed flow rate, we need it as an output for Excel. Right, so we need these as outputs from the model. So for example, flow rate for stream number 7, we would need to extract it, and this one is given as off gas flow rate, this one. So if you see the dynamic data exchange for off gas flow rate, this one is given as output, right? So the outputs are the ones that we're going to extract here, and the inputs are the one that we're going to feed into the model, right? So before you make this, you would need to extract this picture into your Excel, like what I did. So to do this, you just go on to the graphics for MedSim. Just click on the graphics so that we can extract a very nice picture of this flow rate. Then you go on to GBMP, send last graphic item to asterisk BMP. If you click this, then find where you want to place it, then you click on save. This will be saved as a picture, right? So if you look, I saved this in the desktop. This is the picture, right? This is the picture. So I would want you to copy this picture and open your Excel. And you paste this into your Excel, right? So we now have this picture in our Excel. You can actually design the your spreadsheet in the way that you want. So we can now play around with it. Like the way I did it. So this is just the picture. I have on my left, I've typed for input, and this is the tank feed for this input. So I'm going to have nitrogen weight fraction, I'm going to have oxygen weight fraction, I'm going to have water vapor weight fraction, and also I'm going to have the total flow rate. For each stream. So stream number 5, right? Stream number 5, this is the stream number 5, is going to be composed of these parameters. All right. So I will feed the feed rate, weight fraction, and also as an input for stream number 8, which is the liquid stream, I'm going to feed the temperature. Right, so the software is automatically going to calculate for me the pressure in the slurry. It's going to calculate the temperature in the slurry. It's also going to calculate the temperatures for the off gas. Right, automatically. So I've designed this in this way so that I can link this in Excel. Right, so then after you have done this in Excel, you save your file, you go back to MedSim, you start to set up your dynamic data exchange variables. So you can just look at this. These are the inputs, right? So you need to set up this US feed flow as input. I think you recall from dynamic data exchange that we did in level 1, US feed flow is a MedSim variable. It's an input. Then you give it the name, task name for your sheet. So in this case, the sheet name is feed. Yeah, so you have to take note of this. This is feed, and the cell where it's going to be to extract this information is named US feed flow. this one. So I've named this cell US feed flow, right? So I'll input that, then I'll click on OK. I will do the same for other inputs, which is the US nitrogen weight fraction, US oxygen weight fraction as my input. These are obviously the inputs. And also as input is the US slurry temperature, right? And the outputs that I'm going to extract from the model into Excel, I'm going to extract the flow rate of stream number 1 as output. So flow rate of stream number 1 is denoted by VMTHS1. So this is obviously going to be an output into Excel, and we're going to use the same sheet, which is the feed, and we're going to put this on a certain cell. So we use this cell row 31 column 5. Right, so this is going to be the cell where this value is going to be exported to, right? So these cells where you want the data to be populated to is the ones that you'll be linking with. So if you want the stream number 8 flow rate to be recorded, that will be on this cell, right? You have to understand the column number for this cell. So in this case, it will be row 13 and column number. You now count the number of columns, then you insert the value here. So row 31 column 8, that's where the output is going to be stored. Then you click the OK. You do the same for other outlet values that are going to be collected, right? So in this case, you'll be setting up the dynamic data exchange input for this model, right? So after you've done and set up all the variables, you proceed to go on to tools and you test your dynamic data exchange, right? So if you test your dynamic data exchange, it's supposed to populate all the scalars that you would have missed in your setup. But it will give you a confirmation that everything has been set up between Excel and MedSim. So this is what we just did to extract the graphics, and this is how they have designed their flow sheet. So this is typically important when you automatically want to extract your results into Excel in a more customized way. So you can extract critical information from the spreadsheet directly into Excel, and running MedSim um, in its silent mode from Excel, and subsequently getting the results working in Excel. So after this has been done, we would need to add a button, a VBC button, Visual Basic Code button, into Excel, so that we can be able to run MedSim using that button. So to add that button, you need to add just a small code. In VBA, this code will recall the location for MedSim file that you are working on, and also the location of the spreadsheet. So it is important that when you are saving these two files, the MedSim file as well as the Excel file, you save them in your C drive in one folder. So to avoid confusion, you just copy your files and save them in the MedSim folder as specified here. Then you give the code the exact name of the file. So I've saved it as adjust in my C drive. This one, right? So I've specified that as on the code. So you will have a guideline of how to set this using the instructions in the example. So you'll be able to follow this prompt and be able to view the results in Excel once everything has been done. So this is also the instructions for running MedSim from Excel in silent mode. These are the detailed steps that you would need to follow. They are pretty much straightforward. Right. So that's pretty much about this exercise. The important thing about this exercise that I wanted you to learn was to set up the scalar variables as part of your control, and also to understand the use of scalar variables in a PL function formulation, and also the use of scalar variables in dynamic data exchange, and also to learn how to link MedSim with the Excel, and also extract valuable information directly into Excel. I understand that some of the organizations, they use MedSim, they use Excel a lot in analysis of data, and MedSim will become handy in that regard. So I just wanted to show you that you can extract any information about your model into Excel and run MedSim as part of your Excel through that linkage, and also in silent mode. So this will become handy for large flow sheets, whereby we can do the same for each section and extract different information. Thank you.